All right, guys, we're going to talk about functions and function notation. So functions can also be represented by an equation. All right, an equation is also known as a rule. The equation will generate ordered pairs by taking an input, which is your x, and that results in an output most of the time, which is called y. Okay, sometimes we use other variables, but most of the time we use x and y. So input would be your x's, output would be your y. The graph of an equation is the set of all its ordered pairs, which often forms a line or a curve. All right, moving on down, we're going to look at another way to look at function. Think of a function like a machine that makes the x's and produces the y's. So what it does is it takes your x, it puts it into the function, and out comes the y. So your x is your input and the y is your output. All right, so the x value is called the independent variable because you pick it and you can put any number you want to in the equation. The y value depends on what x's you pick. Okay? All right, looking at some examples. So if we look at some examples of functions, y equals x plus 4. We know that this is a function because all the x's are unique. -5, -4, -2, 0. So we get to pick our x's. In this example, they have already given us the values to pick, which makes it easier to substitute these in. So take 5 and plug it into your function and see what you get. All right, if I take -5 and I plug it in for x, -5 plus 4 is -1. And then I take -4 and I put it in for x. -4 plus 4 is 0. I take -2 plus 4, I get 2. And I take 0 and add it to 4, I get 4. Now that you have ordered pairs, you can graph those. Remember, your x goes left and right, so -5 would be 1, 2, 3, 4, 5 to the left of 0, and then down 1 puts me in my third quadrant, and that's where I graph the first point. All right, -4, 0, -1, 2, 3, 4, 0 is my second point. -2, +2 is my next point. And 0, 4, 1, 2, 3, 4 is my last point. Now let's see if I can draw any kind of line here. And that is the line of this equation, which also goes through that set of points. All right, so the first thing is take your x's, which are your inputs, plug it into the equation to find your output or your y, and then graph the points. And that's one way to graph a linear equation. All right, number 2, if I take -4 and I plug it in for x, I'm going to say -4 times 3/4 is going to be -3. -3 minus 2 is -5. Take 0 times 3/4 is 0 minus 2 is -2. And 4 times 3/4 is 3. 3 minus 2 is 1. And then take 8 and substitute it in. 8 and 4 reduce gives me 2, so that gives me 6 minus 2, which is 4. All right, again, once I have my ordered pairs, I'm going to graph those. I'm going to go 1, 2, 3, 4, and then down 1, 2, 3, 4, 5. And then I've got 0, -2, I've got 4, 1, 2, 3, 4, up 1, and 8, 4. And that one is off the graph, so I'm not going to worry about graphing that last point since my graph doesn't go up that far. Looking for my line again. There it is. All right. I'm going to skip down to number 5. So if you look at number 5, and again, we're given our independent or our x's, we're given our input values, and our input values this time are -3, -1, 0, and 4. I'm going to take that, each number, and plug it in for x again. So we've got negative as part of the equation. -3 makes that +3. 3 plus 1 is 4. I'm going to take negative times -1, which is 1. 1 plus 1 is 0. And then take 0. -0 is still 0. Plus 1 is 1. And then minus 1 times 4 is -4. Plus 1 is -3. So I'm going to go left 1, 2, 3, and up 1, 2, 3, 4. And then I'm going to go -1, 0. I'm going to go 0. I did something wrong there. Let's see. Let me back up a minute. Something is not right. Okay, so make sure my points are correct here. So -3, that's 3 plus 1, which is 4. -3 up 4. And then I've got -1 plus 1. That is 1. Okay, so that's 1 plus 1, which is 2. That's where I messed up. Okay. I know these are linear equations, so it has to be a straight line, so I knew I'd messed up. All right, so 0, -0. So 0 plus 1 is 1. And then -4 plus 1 is -3. All right, so I've graphed -3, 4. And now I'm going to do -1, +2. And then 0, 1. Now it's lining up straight. And 4, 1, 2, 3, 4, 1, 2, -3. All right, so anytime I'm working with a linear equation, this is a good time to say, make sure you know that a linear equation should be a straight line. When my points were not lining up, I knew I had done something wrong. Good way to check yourself. All right. Let's look at number 6. Again, our independent variable x's, they have been given to us, so we're going to take these numbers and substitute them in for x. -1/3 times -3, that becomes 2 negatives is a positive, and the 3's cancel, so that's 1. So 1 plus 1 is 2. All right, take 0. 0 times anything is 0. 0 plus 1 is 1. 3. -1/3 of 3 is -1. -1 plus 1 is 0. And then -1/3 times 6. -1/3 of 6 is -2. 1 plus -2 is -1. So if we graph those, I'm going to go -1, 2, 3, up 2 for the first point. I'm going to go 0, 1 for the second point. I'm going to go 3, 1, 2, 3, 0. And I'm going to go 1, 2, 3, 4, 5, 6, -1. All right, I'm going to graph those. And that is almost in the right spot. Let's see if I can move that down just a tad. I don't know if I can. It's not changing the angle, but hopefully you get the point. All right, so this is how you are going to take a table of values and use it to plug numbers into your function and graph it. All right, so on this part it says given each function and domain, find the range. So we're looking for the range. Remember, the range is the y values. So we are going to look for the range. All right, so we're going to take our domain and one at a time plug it into our function. So the first number in our domain is 4. So we're going to go y equals, remember y is our range, so we're looking for our range. And 4 minus 5 is -1. And take 6, the second number here, plug it in. 6 minus 5 is 1. And take 8 minus 5 is 3. So our range is -1, +1, and 3. For number 8, we're going to plug in our domain again, in for the x's. So our range is going to equal, we take -1 and plug it in. -1 times 3 is -3. -3 plus 1 is -2. 0 times anything is 0 plus 1. 1 times 3 is 3. 3 plus 1 is 4. And 4 times 3 is 12. 12 plus 1 is 13. All right, for number 9, same thing. We're going to take our domain. Domain is our x's. We're going to plug it in for x. And we're going to find our range, which is y. All right, so take -2 times -1 is 2. 4 plus 2 is 6. 3. So this makes this 4 minus 3. 4 minus 3 is 1. Take 5, plug it in. 4 minus 5 is -1. All right, for the next one, same thing. We're going to find our range by plugging numbers into the function. So our range, so take -10, plug it in for x. 3/5 times -10 is -6, plus 2 is -4. Take 0, 0 times anything is 0, plus 2. And then 5 times 3/5 is 3. 3 plus 2 is 5. All right, if you can't do that in your head, you can use a calculator to plug those in and find them. But mental math is always something good to practice. Hopefully you understand how to find the range given the domain.